Section 314.17 of the National Electrical Code addresses the rules for installing conductors of different circuits within the same enclosure. It specifically states that conductors from different circuits should not occupy the same raceway, cable box, or cable tray. However, there are exceptions outlined in subsections 314.17 through D. In the context of installing a 14/3 and a 14/2 cable within the same 4-gang box, this generally isn't permitted because these cables typically serve different circuits. The code aims to prevent overloading and potential short circuits by keeping unrelated circuits separate. One exception to this rule involves multiwire branch circuits. A multiwire branch circuit is a circuit that includes 2 or more ungrounded conductors that share a neutral conductor and are supplied from a single phase of a 3-wire system or derived from a 3-phase system. If the 14/3 and 14/2 cables are part of such a multiwire branch circuit, then installing them in the same box is permissible. To clarify, consider how a multiwire branch circuit works. For example, in a 120/240 volts single-phase system, you have 2 120 volts legs that are 180 degrees out of phase with each other. These 2 legs, along with a shared neutral, can supply 2 separate 120 volt circuits. Because the loads on each leg are never perfectly balanced, the neutral conductor carries only the imbalanced current. This configuration allows for 2 circuits to be served with less wiring. If the 14/3 and 14/2 cables are wired in this manner, they can be in the same box. However, ensuring the box is adequately sized to accommodate all conductors is vital. Box fill calculations must be performed according to NEC guidelines. This ensures that there is sufficient space for heat dissipation and prevents conductors from being damaged due to overcrowding. The NEC provides specific rules for calculating box fill based on the number and size of conductors, device yokes, and internal cable clamps. If the 14/3 and 14/2 cables are not part of a multi-wire branch circuit, they must be installed in separate boxes. This ensures compliance with the NEC and maintains electrical safety. Another important consideration is the proper identification of circuits. All conductors must be clearly identified to indicate their source and purpose. This helps prevent accidental contact with live wires and facilitates troubleshooting. Proper labeling of circuit breakers and corresponding wiring is essential. Furthermore, ground fault circuit interrupter protection, known as GFCI, may be required depending on the location and application of the circuits. GFCIs are designed to detect ground faults and quickly de-energize the circuit, preventing electrical shocks. The NEC specifies where GFCI protection is required, such as in bathrooms, kitchens, and outdoor locations. It is also important to ensure that all wiring and connections are made in accordance with the NEC. This includes using approved wiring methods, proper splicing techniques, and secure connections. Loose or corroded connections can cause overheating, arcing, and even fires. Regular inspections and maintenance can help identify and correct potential problems. When working with electrical systems, it is crucial to follow all safety precautions. Always to energize circuits before working on them, and use appropriate personal protective equipment such as insulated gloves and safety glasses. If you are not comfortable working with electricity, it is best to hire a qualified electrician. They have the knowledge and experience to perform electrical work safely and in compliance with the NEC. In summary, while the NEC generally prohibits mixing conductors from different circuits in the same enclosure, there are exceptions for multi-wire branch circuits. Always perform box fill calculations to ensure adequate space, and follow all safety precautions when working with electrical systems. Consulting with a qualified electrician or electrical inspector can help ensure compliance with the NEC and promote electrical safety. Remember to always refer to the latest edition of the National Electrical Code for the most up-to-date requirements. The NEC is updated every 3 years, so it's crucial to stay informed about any changes or revisions. Additional considerations involve the type of wiring method used. Non-metallic sheath cable, also known as NM cable or Romex, is commonly used in residential wiring. However, the NEC specifies limitations on its use in certain types of construction and locations. For example, NM cable is generally not permitted in commercial buildings or in damp or wet locations. In these cases, other wiring methods such as conduit or cable with a moisture-resistant jacket may be required. The ampacity of conductors is another crucial factor. The ampacity is the maximum current that a conductor can carry continuously without exceeding its temperature rating. The NEC provides ampacity tables based on conductor size, insulation type, and installation conditions. It is essential to select conductors with adequate ampacity for the intended load. Overloading conductors can cause overheating, insulation damage, and even fires. Proper grounding is also essential for electrical safety. Grounding provides a low impedance path for fault current to return to the source, tripping the circuit breaker or fuse and preventing electrical shock. The NEC specifies grounding requirements for different types of electrical systems and equipment. All metal enclosures, such as electrical boxes and equipment cabinets, must be properly grounded. Grounding electrodes, such as ground rods or metal water pipes, must be installed to provide a connection to earth. Surge protection is another important consideration, especially in areas prone to lightning strikes or power surges. Surge protective devices, known as SPD, are designed to protect sensitive electronic equipment from voltage spikes. The NEC requires SPD in certain applications, such as at the service entrance of buildings. SPD can also be installed at branch circuits to provide additional protection for specific equipment. Arc fault circuit interrupters, known as FSIs, are designed to detect arc faults, which are dangerous electrical conditions that can cause fires. The NEC requires FSIs in many branch circuits that supply dwelling units, such as bedrooms and living rooms. FSIs can detect arc faults before they start a fire, providing an extra layer of protection. In addition to the NEC, local electrical codes and regulations may also apply. These codes may be more stringent than the NEC, so it is important to check with your local building department or electrical inspector to determine the specific requirements in your area. Proper electrical design and installation are essential for ensuring the safety and reliability of electrical systems. Consulting with a qualified electrical engineer or electrician can help ensure that your electrical system meets all applicable codes and standards. Regular inspections and maintenance can help identify and correct potential problems before they become serious hazards. By following these guidelines, you can help prevent electrical accidents and protect your property and family. Always prioritize safety when working with electricity, and never hesitate to seek professional help when needed. The principles behind these regulations are rooted in physics. Current flows through conductors, and the amount of current a conductor can safely carry depends on its size and material. When conductors are overloaded, they heat up, which can damage the insulation and cause a fire. The NEC sets limits on conductor ampacity to prevent this from happening. Similarly, ground faults can occur when a live wire comes into contact with a grounded surface. This can create a dangerous electrical shock hazard. Grounding provides a path for the fault current to return to the source, tripping the circuit breaker or fuse and interrupting the flow of current. The NEC specifies grounding requirements to ensure that this path is always available. Surge protection works by diverting excess voltage away from sensitive equipment. When a surge occurs, the SPD clamps the voltage to a safe level, protecting the equipment from damage. The NEC requires SPD in certain applications to protect against voltage surges. Arc faults are caused by unintentional arcing in electrical circuits. This can occur due to damaged insulation, loose connections, or other factors. Arc faults can generate intense heat and can easily ignite nearby materials. FSIs are designed to detect arc faults and quickly to energize the circuit, preventing a fire. The NEC requires FSIs in many branch circuits to protect against arc faults. Electrical codes and regulations are constantly evolving to keep pace with technological advancements and new safety concerns. Staying up to date on the latest codes and regulations is essential for ensuring the safety and reliability of electrical systems. The NEC is updated every 3 years to reflect these changes. Local electrical codes may also be updated more frequently. In addition to complying with codes and regulations, it is also important to follow best practices for electrical design and installation. This includes using high-quality materials, proper installation techniques, and thorough testing. Proper documentation of electrical systems is also essential for future maintenance and troubleshooting. Consulting with experienced professionals can help ensure that your electrical system is designed and installed to the highest standards. Remember that electricity is a powerful force that can be dangerous if not handled properly. Always prioritize safety when working with electricity, and never hesitate to seek professional help when needed. By following these guidelines, you can help prevent electrical accidents and protect your property and family. This information is for educational purposes only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or electrical inspector before performing any electrical work. The information provided is based on the National Electrical Code and may not be applicable in all jurisdictions. Always check with your local building department or electrical inspector to determine the specific requirements in your area. The NEC provides detailed requirements for electrical installations, including conductor sizing, overcurrent protection, grounding, and wiring methods. Understanding these requirements is essential for ensuring the safety and reliability of electrical systems. The NEC also includes requirements for specific types of equipment, such as motors, transformers, and generators. These requirements are designed to protect against electrical hazards and ensure the proper operation of the equipment. The NEC is a comprehensive document that covers a wide range of electrical topics. It is essential for anyone involved in the design, installation, or maintenance of electrical systems to have a thorough understanding of the NEC. In addition to the NEC, there are other industry standards and guidelines that can be helpful for electrical professionals. These standards cover topics such as electrical safety, power quality, and energy efficiency. Staying informed about these standards can help you improve the quality and safety of your electrical work. Continuous learning and professional development are essential for electrical professionals. Attending training courses, reading industry publications, and participating in professional organizations can help you stay up to date on the latest technologies and best practices. Investing in your professional development can help you advance your career and provide better service to your clients. Remember that electrical safety is everyone's responsibility. By following these guidelines and prioritizing safety, you can help prevent electrical accidents and protect your property and family. Always be cautious when working with electricity and never hesitate to seek professional help when needed. Electricity powers modern life, but it demands respect. Ignoring code requirements, cutting corners, or attempting electrical work without proper training can have dire consequences. Think of electrical codes as a set of best practices developed over decades, refined through countless incidents and accidents. They represent the collective wisdom of engineers, electricians, and safety experts. Every requirement, even the ones that seem minor, serves a purpose. For example, the seemingly simple rule about box fill isn't just about squeezing wires into a tight space. It's about heat dissipation. Overcrowded boxes trap heat, which can degrade insulation, leading to shorts and fires. Similarly, grounding isn't just about sticking a wire into the earth. It's about creating a safe path for fault current to flow, tripping a breaker and preventing a potentially lethal shock. Multiwire branch circuits, while efficient, require careful attention. A shared neutral can become overloaded if the loads on each leg are not balanced, leading to voltage drops and potential damage to equipment. Always use a clamp meter to verify that the neutral current is within acceptable limits. Arc fault circuit interrupters, RFCs, are a relatively recent innovation, but they have already saved countless lives. They can detect the telltale signs of an arc fault long before a standard breaker would trip, preventing fires from starting in the first place. Don't be tempted to bypass or disable safety devices. They are there for a reason. If a breaker trips repeatedly, don't just replace it with a larger one. Find the underlying problem and fix it. Surge protection is often overlooked, but it can save your valuable electronics from being fried by a power surge. Install surge protectors at the service entrance and at individual outlets to provide comprehensive protection. Regular maintenance is also crucial. Inspect your electrical system periodically for any signs of damage or wear. Look for cracked or frayed wires, loose connections, and corroded terminals. Replace any damaged components immediately. If you are not comfortable performing electrical work yourself, hire a qualified electrician. They have the training, experience, and tools to do the job safely and correctly. Don't risk your safety or the safety of your family by attempting electrical work that you are not qualified to do. Electricity is a valuable resource, but it must be treated with respect. By following these guidelines and prioritizing safety, you can enjoy the benefits of electricity without putting yourself or others at risk.